For outlier, once again, you have to recall a little bit about the lower quartile. You know, the lower quartile will represent by Q1. In the same way, uh, Q2 is median, which is called middle quartile, that is Q2, and upper quartile is represented by Q3. Q1 is 25% of the data. In the same way, Q2 is the 50% of the data, it's the median, and Q3 is 75% of the data. Or we say if the total number of values are n, then Q1 will be 1 over 4 of n. That value is the lower quartile, and median is 1 over 2 of n, and upper quartile is 3 over 4 of n. Now, an outlier we can define in two ways. For example, let me say if this our whole spread of the data, then your Q1 might be here, Q2 here, Q3 here. Now your outlier, if outlier is not defined, in most of the cases, the definition of the outlier is given within the question. If a special outlier is there, otherwise you can remember that your outlier can be, we can define our outlier in two different ways. One of the way to define the outlier is it might be either greater than Q3 plus, no, instead of that one, why not to take it in my own way? It might be either greater than Q3 plus 1.5 times of IQR. What is IQR? You already know about IQR. It's interquartile range, which is always Q3 minus Q1. It is always 1.5. Okay, a value greater than this one, if it belongs to the data, then we will call it it's an outlier, or it might be less than Q1 minus 1.5 time of interquartile range. Then we will say it's an outlier. So our data may have an outlier greater than Q3 1.5 time of interquartile range. Then we will say it's an outlier. Okay. Or it may be less than Q1 minus 1.5 time of interquartile range. These two things you have to remember. Let's see a question related to the interquartile range, to the outlier, exercise 3b. Then you will have a better and clear idea about how we will solve the questions related to this one. Let me take this. For example, this first question given here. Now you have to remember these two formulas. And sometime for every question, outlier definition may be given. If not given, then you will use this definition of the outlier. Now it is given here in this question. Q1 is given 46, Q3 is given 68, and the definition of the outlier is that a value greater than this one or less than this one. So it means the definition of the outlier is given. Using this rule, work out whether or not the following are outlier. These three values are given, so we have to check, can we take 7 as an outlier or not, 88 as an outlier or not, 105 as an outlier or not. So first of all, you should find this value and this value. Then you will be able to. So what is actually, this one is our IQR, interquartile range. So first find your interquartile range, which is Q3 minus Q1. Now what is this one? It is Q3 is 68. So write 68 minus Q1 is 46. So 68 minus 46. Okay, let me take this one. It is 68, sorry, 1 second. 68 minus 46 is 22. Now, first find this factor, Q3 plus 1.5 time interquartile range. So what this will be, Q3 is 68 plus 1.5 into 22. Calculate this one. It is 68 plus 1.5 times 22. That is 101. Okay. Then find this second factor, Q1 minus 1.5 times interquartile range. So what this will be, what is Q1? Q1 is 46 minus 1.5 of 22. So what this will be, 46 minus 1.5 into 22 is 13. It means, as we are saying, an outlier will be greater than this one or less than this one. If the value is not greater than this one, it will not be an outlier. If it is not less than this one, it will not be an outlier. Now talking about 7, look, 7 is less than 13 or not? It's clearly less than 13. So therefore we will say 7 is outlier. And the same way 88. 88 is not greater than this one or neither less than this one. So in this situation, we can say 88 is not less than 13 or 88 is even not greater than 101, because outlier should be greater than this one or less than this one. It means we will say 88 is not an outlier, because the reason for being outlier is it should be greater than this value or less than this value. So it's not fulfilling any one of these definitions. So that's why it's not an outlier. Okay, about 105. Yes, 105 is greater than this one, so it is an outlier. We will say 105 is less than, is greater than 101. So any value greater than this one will be declared as an outlier. So we will say 105 is an outlier. Okay. So in this way, you will decide whether a given value in the data is an outlier or not. Clear? Now, let's take the second question. Please let me know if you have any confusion about that. If not, then let's move to the second question. The question is, the masses of male and female turtles are given in the grams. For males, the lower quartile was 400 grams. This is, I have the two parts of this data, male and the female turtles. First of all, let's write the data for the male. The lower quartile for the male is, in Q1, is 400 grams. And the upper quartile is 580 grams. Is 580 grams. For females, the lower quartile is 260. 260. And the lower quartile is 340 grams. An outlier is an observation that falls either 1 into interquartile range. This time the definition is changed. Okay. Usually it is 1.5 above Q3 or 1.5 below the Q3 of interquartile range. But this time it is given 1 time interquartile range above the upper quartile. Mean it is given that the definition is given for the outlier. This time it is Q3 plus 1 into interquartile range. Mean 1 time of interquartile range more than the upper quartile range, and or 1 time below the lower quartile range. So it means it's given that it can be Q1 minus 1 into interquartile range. So sometime it might change, but if no definition is given, then it will be for 1.5. So the question is, which of these male turtles would be outliers? Some values are given, so we have to check whether they will be an outlier or not. So first check interquartile range for this one. What this will be, 580 minus 400, which is 100. In the same way, find interquartile range for this one also, which is 340 minus 260. So 340 minus 260 will be 80. That is. So for both of these, as we are talking about the male turtle, first we have to check. So find Q3 plus 1 time interquartile range. So what this will be Q3 for the male is 580 plus 1 into interquartile range, which is 100. So that will become 680. So any value greater than this one will be an outlier, or the other possibility for the outlier is Q1 minus 1 into interquartile range. So what is that one? 400 minus 1 into IQR, interquartile range. Interquartile range is 100. So that is 300. So any value less than this one also in grams, because the units are grams, so you will write that. So either any value greater than this one for male or less than this one will be outlier. Okay. So what about this one? Will it be an outlier? No, it cannot, because it is not greater than this one, not less than this one. So it is not an outlier. Okay. Then 260. Yes, 260 is less than this one. So this is an outlier, because an outlier will be either less than this or more than this. So 260 is less than 300. So it is an outlier according. 550. 550 is not greater than this or not less than this one. So it is not an outlier. 640. 640 look is not greater than this one, not less than this one. So it is not an outlier. Okay. Now, in the same way, number B. For number B, now which of these female turtles would be outliers? Now for females, calculate the same factor. Q3 plus 1 time interquartile range. Now for the female is 340 plus 1 into 80. So 340 plus 80, this will be 420. And then it means if any value is greater than this one, it will be an outlier, or Q1 minus 1 time interquartile range. So what this will be, Q1 is 260 minus 1 into interquartile range, that is 80. So 260 minus 80, if I will take 260 minus 80, we will get 180. So if any value less than this one will be outlier, or any value greater than this one will be an outlier. So look at this one, 170. Yes, 170 is less than this one. So it is an outlier. 300 cannot, because it's not either greater than this or less than this. 340, no. 440, yes, it is greater than this one. So it will be an outlier. And keep in mind, a data can have more than one outlier. It's not must that a data will always have one outlier. It can have many outliers. Any value in the data that will fulfill this one will be declared as an outlier. And then part C is saying, what is the largest mass a turtle can be without being an outlier? Okay, without outlier, which is not an outlier, and the largest possible value of the mass of the turtle. So if we look at this one, what it can be, the question is, what is the largest mass of a male turtle can be without being an outlier? Largest mass of the turtle without an outlier. It should not be outlier, but the largest value. Which is not the outlier and is the largest value. So clearly you can see it is 640 grams. It is not outlier and is the largest value. Okay. So this will be 640 grams will be the answer for this one. Clear? All right. Number 3. The masses of Arctic foxes are found and mean mass was 6.1 kg. This is the mean mass. The variance was 4.6. Okay, let's write the given data first of all. Mean. Mean is 6.1 kg. Variance. Okay, variance is given 4.2. An outlier is an observation lies plus minus 2 standard deviation from the mean. Now this time the outlier definition is given this one. First of all, you need to find the standard deviation. You know what is standard deviation? We know very well, we discussed it previously, that the standard deviation is square root of variance. It means what is standard deviation? It is 4.2 square root. Okay. Now according to the definition, it is given that an outlier is an observation plus minus 2 standard deviation from mean. What does it mean? It means it will be either mean plus 2 into standard deviation, or it will be mean minus 2 into standard deviation. These are the two definitions of the outlier given. Okay, because it is from mean either mean plus 2 times of standard deviation or mean minus 2 times of the standard deviation. So use this definition and find, and then decide which of these is an outlier and which of these is not an outlier. So mean, what is mean? Mean is 6.1 plus 2 into standard deviation is square root of 4.2. Okay, let's calculate this one. It will be 6.1 plus 2 into square root of 4.2. Oh, sorry. 6.1 plus 2 into square root of 4.2. So that is 10.198. That if I will round to one decimal place will become 10.2 approximately. Okay, so you can say it is approximately 10.2. Then take this one, mean minus 2 into square root of 4.2. So that will be 6.1 minus 2 into square root of 4.2. So that is 2.00. Mean you can say approximately 2.00. So now let's check this one. Can this be an outlier? No, because it is not less than this, not more than this one. So this is not an outlier. 10.1. No, 10.1 cannot be an outlier. Why? Because it is not greater than this, not less than this. So it's not an outlier. 3.7, not an outlier, because not greater than this, not less than this. 11.5, yes, 11.5 is an outlier because it is greater than 10.5 at 10.2. So this one is an outlier. Then part B is saying which are the smallest and largest masses that an Arctic fox can be without being an outlier. Saying without being mean it should not be outlier, then without outlier the smaller and the largest value. Okay, the smallest value without being an outlier. Okay, that can be without being an outlier. Now without being it mean it should not be an outlier, and then the smallest value. So that is in that case, if you know, I will say first of all, we have only one outlier. Mean we cannot take this one. Other one, we can even take this one because you know these become the largest or the smallest values other than the outliers. Okay, if you are taking the outlier, your data spread was like this one. First of all, for example, let's see if this was like before your data spread was 2.4, then it was 3.7, then it was 10.1, then it was 11.5. Now 11.5 is an outlier. Being outlier, we will say we cannot take this. Then this value is now also the part of the data. So 10.2 will be a value, the largest possible mass without outliers, because we calculated this one. This is also now the part of the data. So this one will be. And then the smallest value without an outlier. So now even none of them is outlier. So even 2 is less than this one because it is now part of the data. So we will say it is. So that will be 10.2 is the largest and 2.0 is the smallest value. Okay. So this point further, when we will draw actually the outliers and the data, outliers data, we will discuss them further there. The ages of 9 people at children's birth party are recorded. Sigma X for them is 92. Okay, sorry. Sigma X is given 92. Sigma X square is 1428. Calculate the mean and standard deviation. The total number of people, mean N is given 9. You have to calculate the mean and standard deviation. Now, what is the formula for the mean? Mean is equal to sigma x over n. This we used in the previous unit. So it's sigma x over n. Sigma x is 92 over n is 9. So 92 over 9. That is 10.2222. That you can say is 10.2. Okay, 10.2 is the mean. Then standard deviation. What is the formula for the standard deviation? If we will write the formula for the standard deviation, we know the standard deviation is square root of sigma x square over n minus sigma x over n square. This is for ungrouped data. If you remember, we took the standard deviation for the ungrouped data. So in this case, what this will be, put the definition, put the values here. What is sigma x square? 1428 over 9 minus sigma x is 92 over 9 square. So let's calculate that one. 1428 divided by 9 minus 92 over 9 square, 7.36. So you can say 7.36 is the standard deviation. Then question is saying an outlier is an observation which lies plus minus 2 standard deviation from the mean. An outlier will be either mean plus 2 times of the standard deviation, or it will be mean minus 2 times of the standard deviation. One of the ages is recorded as 30. State with the reason whether or not this is an outlier. So you have to check that 30 is an outlier or not. So first of all, calculate these two factors, then you will be able to decide whether it is an outlier or not. So what is mean? Mean is 10.2 plus 2 times 7.36. What this value will be? 10.2 plus 2 times 7.36. That is 24.92. Now calculate this one. 10.2 minus 2 into 7.36. What that will be? 10.2 minus 2 times 7.36. So it will be minus 4.52. Now, in this case, do you think that 30 is an outlier? Yes, it is an outlier. Why? Because it is greater than this value. So any value greater than this or less than this will be an outlier. Okay. So we will say as 30 is greater than 24.92. So therefore it is an outlier. Then suggest a reason why this age could be a legitimate data value. Now, when we say a legitimate data value, so because as being an outlier we can make the part of the data. An outlier, when you say a given value is an outlier, so will be the part of the data. So if we have to say that, if we have to give the reason for that one, so it means it can be the age of the person, whatever is, okay? It can be age of the children. As it is an outlier, so an outlier can be the age of the children. That is why it is a legitimate value. Then part D is saying, given that all 9 people were children, can you just hold on for 1 second, please? Okay, part D is given that all 9 people were children. Clean the data and recalculate the mean and the standard deviation. Now this time, as it is said that all 9 people were children, you have to clean the data and recalculate the mean and standard deviation. If you look, initially, sigma x was 92. Whenever you reclean the data, for recleaning the data, you will take out the given, because as it is said that one of the edges is recorded, 30 was included now. So what you have to do, you have to reclean the data. It means now from sigma x, what you will do, you will minus 30. Okay. So in that case, what this will become, 92 minus 30 will become 62. Okay. So in the same way, for the standard deviation from sigma x square, you will minus its square, 30 square, because it's the square of the values. So that will become from this one, 1428, you will minus 30 square. So what this will give you? That will give you 528. Now this is your new sigma x actually. Okay. And this is your new sigma x square. So in that case, you can find the new mean. New mean in that case will be equal to 62 divided by 8, because now there are 8 values. One of the value which was 30 being an outlier, we take it out. So that will be, and your standard deviation in that case will become square root of 528 over 8 minus 62. Oh, sorry, not 30, over 8, because total number of values are 8. So over 8 square. That will be your new standard deviation. Okay. Actually, when I will draw this one, you will get more clear about that. Mean how when we readjust a given outlier in the data. Okay, yes. In the box plots, you will be more clear about that one. When we draw the box plots in the new latest IGCSE syllabus, I think Zainab, you took this one, yes? The box plot recently, because you just cleared Zainab, Abdullah, Saleh, you took these with me already. I think, yes. Okay, so whenever we make the box plot, it is actually a box like this one. So this value will be the lowest value of the data other than an outlier. It should not be the outlier. Okay. And this is the highest value of the data other than the outlier. Here we write Q3, upper quartile. Here we write the median, and here we write the lower quartile. An outlier can be either here or it can be here. It depends on the data. Okay. So let's see. Take the question about the box plot. You'll understand how we have. Okay, here we are having the exercise 3C. Question is saying a group of students took a test. The summary of the data are given below. This is the lowest mark, lower quartile, median, upper quartile, highest mark. Given that there were no outliers, draw a box plot to illustrate the data. Okay, we will make a box plot here. For making the box plot, what I need to do is, obviously when we will have the box plot, so what you should do, you should just, you can take, let me say, 1 second. Just share, make a line. And on that line, what you should do for your data, as you know, look at this is the lowest mark, this is the lower quartile, median, upper quartile, and this is the highest mark. So you should make a scale. For making the scale, like I can start from here. Lowest mark is 5, so I can make a gap of 5, 5, okay? Like this 0, 5, 10, 15, 20, 30, 35, 40, 45, 50, 55, 60 is enough. Then you have to make the box now. First of all, you have the lowest mark. For the lowest mark, okay, let's say this is lowest mark. So I will say this one is, you will draw a line for that one. Then for the lower quartile is 21. This is 20, so 21 will be almost here. Draw a line. And in the middle of that, make a line to join these. Then you make the box always for the lower quartile and upper quartile and the median. What is median? 28. So 28 will be almost here. This is your median. Then upper quartile is 36. This is 35, so 36 is this. So you will make a box for this one. This is called a box plot, or also another word is used for this one, whisker. Okay, whisker or whisker. I don't remember exactly. Whisker box. Okay. So this one is your Q1, Q2, Q3, and then the highest mark. The highest mark other than a quartile is 58. So 58 will be, you can say here. So from the middle, join them. That will become your, we will say this is our box plot. Simply we draw this one. This is the lowest value, Q1, Q2, Q3. You can see this spread is more than this one. And this is the highest value other than a quartile. All right. Now, let me say, I'm going to add here one thing additionally. If someone says that now you have to remake this box, like this box is given with this data, okay? And someone says remake the box when you have, let's see, there will be question of like that type. Let me say, maybe if we have, yes, let's say question number 2. The question is saying, here is a box plot. Write down the upper and lower quartiles. Now, this is upper quartile. First of all, check from 10 to 20, how many boxes are there? Let me make it a little bit bigger so it will be more visible to you. because we have to check like 1, 2, 3, 4, 5. So 5 boxes are making 10 numbers. 5 boxes equal to 10. So it means one box will be equal to 10 over 2, which is 10 over 5, sorry, which is equal to 2. It means each box represents 2. Now this is 30, so this one is 32. So it means you will say your Q1 lower quartile is 32. Upper quartile now, this is upper quartile. Now this one is, let's see, this is 40, 42, 44, 46, then half of this one, 47. So Q3 is 47 because you know it's between 48 and 46, so it is 47. Write down the median. This one is median. Median is where on 38. So median Q2 is 38. Then work out the interquartile range. What is interquartile range? IQR. It is Q3 minus Q1, which is 47 minus 32. That is 15. Okay. Then work out the range. Now range you know is the highest minus lowest. This is the highest value. What is this one? 76. So range will be equal to highest value minus lowest value. This is the lowest value, 12. But this one is 64. That is okay. Now till this one, you should